So in the previous video, we walked through how to design a class, how to decide what becomes a field and what becomes a method, what the behaviors of our class are. In this video, we're going to implement our class. We're actually going to take this design and turn it into something concrete, something that we can actually use. Let's go back up to the top and start with the fields. Fields are pretty easy. For each field, we have a few things we need to specify. I'll do the first one for you and explain the different pieces. The first field on our list is the memory. So I'm going to say private int memory semicolon. And I have now effectively implemented that field. So what's going on here? I see another access modifier. This time I'm using private. In fact, all fields should be made private with a few exceptions that we'll see in later concepts as we go through the class. But for now, most of your fields should be declared as private. There's a very good reason for doing so. We want to be able to control the access to these fields. We don't want all of these to be exposed to the outside world. Some of these things might only be needed for internal use. If we do need it to be exposed to the outside world, then we can use our behaviors to control access to these fields. And you see that we actually have some behaviors down here that are going to control our access to the different fields. We'll see those later when we actually implement the behaviors of our class. The next value, of course, is the data type, and then finally the name of the field that we are implementing. So let's go ahead and finish this up for the rest of our fields. Private double size, private double processor, and private string brand. Okay, we've now finished implementing our fields. Let's move on to the behaviors. The first behavior that we need to implement is perhaps one of the most important ones, being able to create a computer. Again, this behavior has a special name, so these behaviors are going to become methods, and the method that we use to create a computer is a very special method called a constructor. So let's create our constructor now. Creating methods is very much like what you saw when you created methods when you were writing code in C. So the first thing that we need to do is specify whether it's public or private. In this case, we'll use public. We want this to be able to be exposed to the outside world, which is a good thing. We want other people to be able to create and use this object that we're designing. The next thing that we typically see when we're creating methods or functions is the return type. But noticeably, with a constructor, there is no return type. Instead, we skip directly to the next part, which is the name. And notice that the name that I'm using for this method is the same as the name of the class. That is intentional. The constructor will always have the same name as the class. Next, I'll include parentheses, and inside the parentheses, I need to put any input parameters that this method is going to have. Now for constructors, they have a very special job. By the time the constructor is finished, I want each of my fields to be set to a value. So if I leave any of these blank, if I leave any of these null, my constructor has not done its job. Now there are two ways to go about this. One way is to simply hard code values into these, but that's actually not particularly useful in many cases. Instead, what we're going to do this time around is actually take values for these different fields as input parameters to my constructor. So I'll have an integer for memory, I'll have a double for size, I'll have another double for the processor, and I'll have a string for the brand. So there is the definition for my constructor. The next thing that we need to do is fill out the body of this constructor. Again, remember, the whole purpose of the constructor is to make sure that each one of these fields has a value by the time we're finished. In this case, it's relatively straightforward. We simply take the input parameters and we assign them to the appropriate field values. You can think of these field values similarly to global variables that you might have seen in C. So to set them, I can say memory equals memory. But wait a second, this is a little bit confusing. So what I'm trying to do here is take this field and set it equal to this input value. So that's exactly what I typed out. But if you notice, the computer is a little bit confused by this statement. In fact, it looks a little bit strange to me. I have no way of knowing whether this memory here refers to the input parameter or the field that I declared at the top of this class file. Fortunately, there is a way to distinguish one from the other. There's a special keyword in Java called this. If I ever use this, that means I'm referring to the field of the class, not the parameter, not the input parameter or local variables. So in this case, I want to use this value on the right-hand side of the equal sign, but I want the value on the left-hand side of the equal sign to refer to my field. In order to make that clear, I'm going to say this dot memory, and when I do so, you'll notice that Eclipse turns this blue to indicate that I'm now referring to this field. This is the proper way to set a field variable. In fact, anytime you want to use one of these field variables inside of a method, you should append this dot on the front of it to make it absolutely clear that you are intending to refer to the field variable and not some other local variable or input parameter that might currently be in use. So I'm going to go ahead and set these up for the remaining values. This dot size equals size. This dot processor equals processor. This dot brand equals brand. And now we are finished. We have successfully done what the constructor needs to do, which is assign a value to each one of these field variables by the time that it is finished. Our constructor is now complete. So let's take a look at the remaining behaviors that we specified. We've got a whole bunch that start with the word get. You see, I've got a whole series of these. In fact, each of these refers to a specific field that we've implemented in this class. These are another special category of methods called getters. So I have one for the brand name, the size, the processor speed, and the memory. This goes back to what I was talking about earlier, where we want to be able to control how the fields are accessed. We don't want people to be able to just do whatever they want with these fields. We want to actually control whether they can see these fields, whether they can change these fields, and how they can change these fields. Getters are very, very common, and they're actually very, very easy to implement. Let me show you how to implement the one for brand name. It is a method, so it starts out like all methods do, with the word public. Then I need to specify a return type. Remember, we didn't use a return type here, but that's because it's a constructor, a very special method. So here I'm going to be returning the brand name, and since brand is a string, that means the return type is going to be a string. And now I have to specify the name for this method. The traditional way to do this is to say get, and then whatever field it is that I am using this getter for, in this case brand. There are going to be no inputs to my getters, traditionally. And the body of this is going to be very, very simple. In fact, all I need to do is type return this dot brand. So it's going to take whatever the current value is of the brand and simply return that from this method. Now anybody who has a computer object can easily see what the brand is. Okay, let's quickly implement these for the other fields as well. Public double get size. Return this dot size. Public double get processor. Return this dot processor. And finally, public double get memory. Oops, I'm sorry. Memory has a type of int. Return this dot memory. So we've already taken care of a lot of the behaviors that we specified in our design. We just have a few things that we need to do. The next thing on our list is to add some memory. And in order to make this a little bit more interesting for us, I'm going to put a limitation on how we can do this. I'm going to say that there's a cap on the amount of memory that can be added. At most, our computer can accept 8 gigabytes of memory. Any more than that, and we just aren't going to be able to use it. So we'll say that 8 gigabytes of memory is our maximum. So let's start to design this method. I need to implement the definition first of all. So I'll say public. I now need to decide what the return type is. In this case, I'm not sure a return type is absolutely necessary, so I'll go ahead and use void. Then I'll specify the name of the method. Add memory is a great name for this method. And for the inputs, I need to specify how much memory I'm going to be adding. Since memory is an integer, this input would also probably be well suited as an integer. So I'll call it int new memory. Now inside of our method body, we need to take that maximum into account. So if the amount of memory that we have now plus the new memory that's coming in is greater than 8 gigabytes, we actually don't really want to do anything with it. We just want to leave it alone because that will put us over the maximum amount of memory that we're allowed to have. Otherwise, we can just go ahead and add this value in to the current amount of memory that we already have. So let's go ahead and do that. I'm going to need an if statement. In order to access the amount of memory that I currently have, I need to get the value out of this field. The way to do that, again, is to use the this keyword. So if this.memory plus the new memory that's coming in is greater than 8, in this particular case, I don't really have anything to do, so I'll just go ahead and say return. Else, in this particular case, I want to take this new memory and add it to the current memory that I already have. So in order to do that, I need to grab the amount of memory that I already have, this.memory, and set it equal to its current value plus the new memory that's coming in. Well, its current value is still this.memory, and I'll go ahead and add new memory onto it. Oops. That should do it for this particular method. So we've got 2 methods to go. The next one says we want to swap out the processor. So that means I'm going to take a new processor and replace the processor that I currently have. This is another very common type of method called a setter. It behaves very much the way that our getters do up here, but in reverse. Instead of returning a value, I'm going to set the value. So let's go ahead and create a setter for our processor. Public void set processor. And now since I'm taking a value in and replacing the processor that I currently have, I need to use an input parameter. And since the processor is a double, I'll use the double data type to represent that new processor. Double new processor. Now all I need to do is take my current processor and replace it with this new value that's coming in. So again, the value of my current processor, since it is a field, is this.processor. And I'll go ahead and replace it with the value that's coming in, new processor. And that's it. It's a very simple method. Finally, the last behavior on our list is displaying the information about this computer as a string. This is a very special method that should be included in all of your classes called toString. The signature, the definition of this method is going to be the same every time. Public string toString with no input parameters. And then we'll define how we want this to be displayed. So when I call the toString method, I want it to output all of the values that I have, all of the fields that I have in this particular class. So I'll go ahead and start constructing a string that does that for me. Return memory. And here you see the use of the plus operator to do string concatenation, much the way that we did when we talked about PHP or JavaScript. This.memory. Then I'll do the processor. This.processor. Next, I will do the size. this dot size. And finally, I'll do the brand. This dot brand. And that's it. You see that I've created a very long string that includes all of the information that I know about this particular object. Okay, so we've successfully defined our computer object. We've written a fair amount of code here, but we haven't actually tested it out. So once I have this class, you'll notice I don't actually know what the values of these things are. This could be 5, it could be 8, it could be 2 or 1. I don't know what this value actually is. Same thing for the size. I don't know what the actual size value is. And that's because this class that we've written, is just a template. When I'm writing the template, it doesn't matter what the actual values are. I just want to write something that will work for all possible values that this computer might be able to have. So I want it to behave roughly the same way, regardless of what the actual values of the computer are. When I want to use this object then, that's when I care about the actual values that it contains. We call that an instance. So when I use this template, when I put it into action, I create an instance of a computer object. So let me show you how to create and use an instance of this computer object. I'm going to create one more method. It's a method that we've already seen before. Public static void main. I'm going to create this main method down here. And inside of this main method, I'm going to create an instance of this computer object. Now, in order to create an instance of the object, I'm going to use the function, the method that we created and implemented for this purpose. I'm going to use the computer method or the constructor. So let me show you how we're going to call the constructor. I'm going to declare a variable just like I would declare any other variable. The type of the variable, in this case, is going to be the class of the thing that I want to create. Since I want to create a computer, I'm going to use computer as the type of the variable that I'm creating. I'll give this variable a name, just call it my computer. And now I will call the constructor. If I want to call the constructor, my first step is to type in the new word, the new keyword. You see it turned purple. It recognizes this as a special word. Then I'll type the name of the method that I want to call. In this case, computer. That's the constructor. And then you'll recall that the constructor has some input parameters that I need to supply. So I need to tell it what the memory is, the size, the processor, and the brand. So I'll try to use my computer as a reference. I have 8 gigabytes of memory. I don't know what my processor speed is, but I'll just say 2.4. The size is about 15.5 inches, and the brand is Lenovo. I have now successfully constructed an instance of the computer class. Now that I have this instance of the computer class, I can use the methods, the behaviors that I've defined in this computer class. Let me show you how to do that. I can use these getters to get information about my computer and display it to the console, for example. If I wanted to do that, I could say system.out.println, and now I'm going to say my computer. Remember, my computer is the name of the variable that contains an instance to my computer object. And then if I want to call a method on this object, I say dot. And now I can choose the method that I want. So I'll say getBrand, for example. This should return the brand that I set for this computer, which is Lenovo. Let's test it out. I'm going to go ahead and run this. And down at the bottom, you see it says Lenovo, the brand of my computer. But hold on a second. Not all computers are Lenovo computers. There are lots of different companies that make computers out there. In fact, you're probably using a computer that's not a Lenovo computer. So how can we represent that? Well, we would have to create another instance. So let's go ahead and do it. I'm going to say computer, your computer, and I'm going to call my constructor again, new computer. But this time I'm going to use different values. I'm going to try and guess what kind of computer you have. Maybe you have 4 gigabytes of memory. Maybe you have a better processor than me. Maybe it's 3.3 gigahertz. A little bit smaller, 13.3. And maybe you have a Mac. So now I have a second computer. I have 2 instances of my computer class. One is my computer, and one is your computer. If I want to see the brand for your computer, I can use much the same method. I can use the exact same method that I used to get the brand of my computer. So let's try it out. System.out.println your computer.getBrand. Now when I run this program, see what happens. The first thing that it does is it prints out the brand of my computer, Lenovo, but then it prints out the brand of your computer, Apple. How did that work? Well, when I create this constructor, it takes these values in and it stores them in the fields. It stores them in these fields that we created. Later on, when I call the getBrand method, it retrieves the value of the field for that specific instance. Notice that the behavior itself is the same for both your computer and my computer, but the value that's contained in the properties is different. That's what makes instances different from one another, is the values of their fields. Okay, let's try something else. So you remember this method that we made called add memory. I said we have a maximum amount of memory, 8 gigabytes. My computer started with 8 gigabytes, so if I try to add memory to this, I shouldn't be able to because I'm already at the maximum. So I should have the same value that I started with. Let's try it out. I'll say my computer dot add memory. That's how I call a method on this object. And I'll try to add 4 gigabytes of memory. Now, if I want to, I can say system.out.println my computer.getMemory. And if the method behaves the way I expect it to, I should still only have 8 gigabytes of memory. Let's try it out and see. Go ahead and run this program. And you see that the amount of memory it says that my computer has is unchanged. So I tried to add memory, but it didn't work. Okay, well, let's take a look at your computer. Your computer started with 4 gigabytes of memory, so let's try to add some memory to your computer. Since I'm using your computer, I'll start with the instance, your computer. I'll call the add memory method, and I'll add 3 gigabytes of memory to your computer. And now I'll print out how much memory your computer has by changing the instance. Let's see what happens. Since your computer wasn't at the maximum, I would assume that this method would do what it's supposed to and actually add the memory in, which it did. You see that your computer now has 7 gigabytes of memory instead of 4. Again, much like we saw with the previous method, it's using the value that we set during the constructor to perform these actions. The actions themselves are the same, but what determines one instance from another is the value of the fields. And so you see that the value of the fields for each instance is being used whenever we call these methods. That's kind of the magic of object-oriented programming. That's this idea of encapsulation, of being able to define a set of behaviors for every object that will work the same regardless of what the values of that object actually are. It allows us to write a single section of code that works for many, 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 many different objects. It's a very convenient and powerful way of writing programs. The one final thing I want to show you is this toString. So I've been using getBrand and getMemory to pull individual values out. If I want to see all of them, I can use toString. So in order to do that, it's very easy. I can say system.out.println my computer. Notice I didn't even call the toString method on this object. Whenever I call print on the instance of an object, it automatically calls the toString method for me. Let me run this for you and show you what it looks like. Here you see that it dutifully prints out the values that my computer contains: the memory, the processor, the size, and the brand. It got that information by calling the toString method. Okay, we've covered a lot in this video. We're going to do some more work with these in class and in the other exercises, but that's going to wrap it up for now.